Good evening, friends. Yesterday, we have discussed the panel ARDL model. So today, the agenda is to discuss the model with some other data set. And in addition to that, so I'm also try to add the panel co-integration test in addition to the yesterday lecture. And we'll take the new data set. So basic background once again. So question number 1, when and why panel ARDL is required? So panel ARDL is required if you have two type of relationship. Number 1, dependent variable is influenced by its own lag, previous lag. For example, the FDI on a particular year may depend upon the previous year. The GDP growth rate of a country on a particular year may depends upon the GDP on the previous year. So sometimes we have this idea that dependent variable may be influenced by its own lagged value. So this concept in panel data is called dynamic effect. In time series, it is known as AR effect, auto regressive, AR1, AR2. So it depends upon how many lags you are taking. So this is the first scenario. The second is the Y dependent variable is also influenced by the current behavior of X and the past behavior of X. Like for example, GDP may depends upon the export. So we assume that GDP of this year may be influenced by the export of this year, as well as it may be possible that previous export is also contributing to the GDP this year. So the second condition in panel ARDL is when the dependent variable is influenced by the current or contemporaneous value of X and the past values of X. So when you have this kind of model, then panel ARDL is a perfect model to apply. Now the condition is that all the dependent and independent variables, either they are I0 or I1 or mix of I0 and I1. So what is I0? I0 means the variables are stationary at level. I1 means the variables are non-stationary at level, but when you differentiate, it becomes stationary. So they are I1. I2 is not allowed. Now here in this case, there is one point which I want to say. If you are going to apply the panel co-integration test, there are 3 panel co-integration tests available in Stata. The most popular is Padroni. The other are Cow and Westerland. So there are 3 panel co-integration tests available in Stata. That is Cow, Padroni, and Westerland. In EViews, there is one more test, that is Fisher. So these are the panel co-integration tests, and the panel co-integration tests are also applicable to check whether there is a long-term relationship in the model or not. But co-integration is having one condition, that all the variables should be I1. If all the variables are not I1, then you cannot apply panel co-integration test. In that case, you can apply panel ARDL model. So in simple language, I am telling you, if some variables are I0, if some variables are I1 or mix of both, you can go to panel ARDL, but in panel co-integration, all variables must be I1. So this is the condition. So that is a different thing. and panel var. So we are having one more test similar to this, that is called panel vector auto regression model. In panel vector auto regression model, all these series should be stationary. So all these series should be I1 so that they can be converted into stationary, or all these series you can take R should be stationary. So you have one more option to apply that. Now the question is that what we are testing. We are testing three things in the panel ARDL model: the short run coefficients, long run coefficients, and the speed of adjustment. So what is the speed of adjustment? So that concept I'm telling you once again. So what is the concept of speed of adjustment? Let me explain this concept one more time. Suppose there are two variables, like they are moving like this. And suppose these are the two variables. So this is X, this is Y. And assume that it is the production, it is the demand. So sometimes what happens, demand exceeded the production. It may be possible because of some scenario, the demand exceed the production. So this case is called error. Error. It is expected that the both variables should have long-term equilibrium in the long run. But whenever this error comes, because of this error, one of the variable may adjust. Either the demand will come down or the production will go up. So there should be some adjustment. So this adjustment is adjusted by or analyzed by speed of adjustment. So a speed of adjustment is explaining you that in case of disequilibrium in the relationship between the variables, how the variables are adjusted, and which variable will adjust? Dependent variable. Independent variable will not adjust. Dependent variable will adjust. For example, in demand and production, demand will not adjust. The production will adjust, because whenever there is a high demand in the industry, the companies can increase its production. Like for example, in COVID case scenario, all the companies increases their production of the medicines because of the high demand. Demand will not come down. So this speed of adjustment is examined by the speed of adjustment, and speed of adjustment only work when we have long-term relationship. Because if there is a long-term relationship, then speed of adjustment will come. Otherwise, it will not come. The long-run coefficient can also be examined by co-integration test. So long-run coefficient is, we are also having by panel ARDL model, but it is showing you some long-term equilibrium. Short-term effect is called short-term causality. Short-term causality means if there is a change in X, how it is impacting Y. So three things we examine from panel ARDL model. So we are having, as we discussed yesterday, we are having three tests to check panel ARDL, that is PMG, MG, and DFE. And by default, we have to apply unit root test to check that no variable should be I2. The all variables should be I1 or I0. So we can check from panel unit root test. Then we go for panel co-integration. There are three options: PMG, MG, and DFE. And basically, MG is little difficult to apply in Stata. So we normally check between PMG and DFE, and whatever is the best, it is decided by Hausman test. And once Hausman test say it is DFE or PMG, we will go for that, and then we will interpret. So this is the way we go for panel ARDL model. No, the main equation I am showing you, this is the, so let me show you the main equation. Yeah, this is the main equation of panel ARDL model. In panel ARDL model, the blue is representing the short run coefficients, and in this equation, the change in y is the dependent variable, and how it is affected by the change in y previous lag and change in x previous lag. So they are representing the short term causality, and the simple y and simple x, so they are representing the long term causality, long term relationship. So these long term and short term we have to check. And phi, the phi here is showing you the long term effect, and it is coming the name of EC, error correction. And in addition to this, the software will also give you the error correction speed of adjustment. So these three things we examine from the equation. So these, I repeat, when we apply panel ARDL, the software will provide you three things: long-term coefficient, short-term coefficient, and speed of adjustment. So three coefficients you will get, whether you are applying PMG, MG, or DFE. So there are three models, as we know. DFE assume that all long run, short run are same for all companies. MG assume it is different for all the companies, but it is difficult to estimate. So it is really difficult to estimate the MG model, which assumes that long run, short run are different for each company. And in between, we are having PMG model, which say that the long run are same, but short runs are different. So we can identify the short run for each cross section. So we are having three choices. So DFE, MG, and PMG. So then we decide, then we apply Hausman test, which will tell you whether PMG and DFE is better. And the null hypothesis that PMG is better. And if it is rejecting, then we go for another test. So this is the basic theory of the this panel ARDL model. So these are the different commands which we are going to apply. Yesterday we applied all the commands. So today we are going to apply on the other data set. So now I am showing you the data set. This is the actual data set we use in some research. The question is, the research question in this data is, which variable have the significant contribution on GDP per capita growth of the emerging countries? So for I removed some of the companies because but for practice we keep around some 15-14 countries. So, and we are having the data from 2000 to 2017, 2000 to 2017. So we are having the data set, right? And we are going to apply the panel ARDL model on this data set. In this data set, we are having one problem. The country should be in number. Otherwise, the Stata will not take this data set. So I'm just do it fast. So it is basically the cross section. Let me put I, and this is T. So normally we represent I with cross section and T with the year. So we have to assign the number to the countries. So this is first, and second is Brazil. So I hope we are having 15-17 countries. Bulgaria is 3. And when you have the data set, you must also know which is my dependent variable and which is my independent variable. Here GDP growth rate is the dependent variable and all other variables are independent variables. So it will take hardly 1 minute. So we have 14 countries in this data set. Yeah. Save it. And the variable names are quite lengthy, but they are representing GDP per capita growth rate is the dependent variable. Agriculture, life expectancy, health. So these are economic variables. FDI. Actually, in the real data set, we are having more than 25 variables, but for practice, I removed some of them. And let's see now, take the data into Stata. Okay. So Stata 17, I am going to open. First of all, take the data set, import Excel, and we are having country GDP growth rate. Import first row as variable name, but the software will take lengthy name. That is not a problem. Okay. So now you have the variable names here. First of all, you need to declare the dataset as panel data, xt set it. So it is a strongly balanced dataset. Then you need to check two things, whether the correlation between the variables and the unit root of the variables. So I will test for first 4 or first 5. So correlation, let's see. So I want to check which variable is having the highest correlation with the dependent variable. This is one of them. Second, is any independent variable is highly correlated. So like you need to check correlation first. This is one of the assumptions that the correlation between any two independent variables should not be greater than 0.7. Otherwise, it will represent the multicollinearity. So GDP is correlated with this one, but negatively correlated. So this level of correlation is expected to be significant. So this is the first exercise you should do whenever you are having the variables. Then we normally try to check normal regression. So this is the pooled regression model. Just have idea that which variable is having more impact on the dependent variable. Okay, so I take all the variables and find out. So I think some variable is having no observation. Let me check. So you can see this broad money or domestic credit, they are showing you red. So red means the software is not considering them as numeric because of some missing values, possibility of missing values, or some any problem. Yeah, you can see that missing values are there. So if you have red in data set, so it is indicating a problem. Okay. So I have to remove these two variables, or you can correct it in the original data set, then you can use it. So domestic and broad money I'm not using for now. So these two variables I am removing. So this exercise will give me an idea which variable is having significant effect on the dependent variable. Okay, so p value is telling you that agriculture may have significant effect. The individual using internet, gross capital formation. So we have to find out that which variable may be important. But because this is a pooled regression model, so we assume that all countries are similar. So this is the assumption, by default assumption in pooled regression model. But here the objective is not to apply pooled regression model. We are interested in going for the panel ARDL model. So before moving to the panel ARDL model, so we need to apply the unit root test. So we are having the command xt unit root LLC, and I'm going to apply on the first variable GDP per capita, including the trend. Yeah. So the null hypothesis is the panel is containing the unit root, but it is rejected. It means the variable is stationary in nature. So similarly you have to apply for all. And if any variable is found to be non-stationary at level and I2, you have to exclude that. So similarly, I have to apply all. So it is also stationary. And one variable is also found to be significant gross capital formation. Let's take this. So it is also stationary. So all the variables are seems to be I0. One more I'm testing. The individual using internet. So I'm taking these variables because these are, this is non-stationary. And if you take D dot, so we are taking the differencing. And so it is I1 variable. So some of the variables are I0, some of the variables are I1. So it is a perfect combination for ARDL model. So after testing this, so we can also check for long-term equation. So in long-term equilibrium, for long-term equilibrium, we have the test called the panel cointegration test. So let me show you the panel cointegration test. If by command, you can go to statistics, panel data, and co-integrated data test for cointegration. There are 3 tests available in Stata. One is cow test, Padroni test, which is most popular test, and Westerland test. So Westerland test is another third type of test, and you can choose which test you want to apply. Cow test, Padroni test, and when you go for Westerland test, you have two options. Some panels are co-integrated and all panels are co-integrated. So you have two options. So for this time, I'm going to apply Petroni test. This is my dependent variable, and all other variables I can take here like this and submit. So we can go for submit. Result will come here. Now the null hypothesis is that there is no co-integration, and the alternate hypothesis are all panels are co-integrated. So because you can see that all null hypothesis is rejected all the three cases, the null hypothesis is rejected in all the three cases. So it means long-term relationship exists. So we are having the evidence of long-term relationship. So both unit root tests, that some are I1 and some are I0, and the presence of long-term relationship, long-term equilibrium relationship between the variables. So it is a perfect combination for panel ARDL model. So we can report the result of unit root, co-integration, all in the research paper to support that the panel ARDL model is better. Now we are moving to the panel ARDL model. So just for I'm repeating that you need to install the command first. Install xtpmg replace. So first of all, those who don't have the xtpmg by default in the Stata, first of all, you need to install it. Okay, now this is the test. So first of all, I just want to apply mg test, and then I will go for PMG and the DFE test. So this way, in this way, we will move. And to save our time, I am taking only the three variables which are found significant in group in the pooled regression model, because you know that if I take all the variables, it will take a lot of time. So to save time, I'm taking less number of variables. And we don't have multi-collinearity as tested in correlation test, so no problem in taking even all the variables. The command I am typing here, xtpmg. So dependent variable is GDP per capita. So I am taking agriculture found, which was found significant, number of internet users, gross capital formation. So three variables I am taking because I found them significant in the group. So the chances of significant impact is higher in this case. Okay. So LR L dot Y, and then we have to take independent variables. So let me take from here. Okay. And which model we want to apply first? MG replace. So this is the first model I want to apply. But MG model is difficult to estimate in Stata because of some problem. And it is a by default problem in the Stata. Stata is going to solve it maybe after some times. So you can find out only the result by typing E return display. So you can see the result by this. Okay, so in this case, let me explain the results. The long run effect is not found to be significant in this case, MG. Error correction is found to be significant, so it is just contradictory that long-term effect is insignificant. The error correction is significant, so this is contradictory because Normally, error correction is found to be significant only when long-term relationship is significant. Short-run is also significant, found only in one case. So MG is not giving me good result. So I go for another PMG, replace. So let me see what PMG is telling you. PMG means the long-term effect are same for all the countries and short-run effect are different. So, okay, so the result are almost same. The error correction is, okay. So only one is found to be significant. No. The software is calculating, sorry. So by default, I see wrong result of MG. Software is estimating the PMG result. So we have to wait for the result. PMG model assume that the long term are same for all the countries and short term are different. So in this case, we found that the long run effect is significant. Long term equilibrium is significant with agriculture. However, in minus. So this indicates that if agriculture production significantly goes down, it significantly represent the GDP growth rate. So whatever data is saying, I'm just reporting that. So however, it is the surprising, but the result is saying that in long term, the agriculture is having an adverse effect on GDP. The error correction model is significant, and short-term effect is only found significant in gross capital formation. Now we want to see the full effect. Full effect means for all the countries. So you can type full here. Full to see the full. Full means all the countries. Okay, but before going to the full, you need to delete these three because software will estimate again. So drop selected variables and let me try full, because software calculate these three variables or every time. So either we have to use replace or delete it. So now the software will give me the short run coefficient for all the countries individually. So waiting for the result. The long run will be constant for all the countries, but short runs are different. So it will come in hardly 1 minute. So you can see that we have 14 countries in the data set. So I14, the short run effect are this for 14, the short run effect of 13th country. In some cases, it may be significant. In some cases, it may be insignificant. So gross capital formation is found to be significant in I3. And for agriculture, the short run effect is found to be Turkey. So I think 14th country is not Turkey. So agriculture is having a significant effect on GDP growth rate in Turkey. So you can find out that which country, like in this case, agriculture is also found to be significant short-term effect in 12th country. So you have all the 14th countries individual short-term effect. In some countries, because some countries are growing because of agriculture, some countries are growing because of tourism, some countries are growing because of some other reasons. So you can find out what are the individual specific reasons of different countries, because we found that, so whenever we applied this model in our data set, original data set, so we found that there were 3 countries which were growing because of tourism, like Thailand. So we found 2 other countries which were growing because of only tourism. Some countries are growing because of only agriculture, like that. So you can find out that which variable is having short-term effect on the GDP growth rate, apart from the long-term effect. So after applying PMG model, now I'm going to apply the DFE, which assume that all countries are same. So DFE in a small letter, and replace means the software will replace the estimators. So the results are coming very fast. So, but no variable are found to be significant in DFE, although error correction is found significant, and gross capital formation is found significant in all the cases. And okay, so full command will not work in DFE because DFE assume that all short run, long run are same for all the countries, cross sections. Now we are going to apply Hosman test. Hosman test, and here you have to type DFE in capital and PMG small and sigma more. So this is the command. I think I sigma, okay, spelling mistake. Yeah. So here you can see that P value is found to be significant, indicating that the DFE model is better. PMG model is not better. DFE model is better. So we finally have to report the DFE result, but I think this command is having some problem, because whenever I apply this command, I found significant result, but in paper I found that the researchers are reporting the PMG result. Similarly, if you go to the EViews, you know that only PMG model is there. So I think we should report PMG model, PMG results to show our data set, because this Hosman test always gives me the significant p value. So that is maybe by chance or by problem, or it may be a problem. So after that, you need to just report the results. So in this way, if we can apply the panel ARDL model using the Stata. So let's see the EViews also. So what result we have in EViews? So trying to run in EViews. Opening the data. Yeah. So software by default consider is at a panel data. First of all, I am showing you the panel quantification test in this EViews. So select GDP and any other variable if you want, like this. Open as a group, because we already tested the unit 2 test, which we know that some variable are I1 and I0. So ideally, we should not apply quantification test here, but just to show you the command. Because co-integration we can apply only when all the variables are I1. So co-integration test. So panel co-integration test. In panel co-integration test, you have three options in this case: Pedroni, Cow, and Fisher. Pedroni and Cow are based on Angel Granger based test, and Fisher is based on combined Johnson. So let's go for Pedroni. But ideally, we should not apply co-integration because of the data set. Most of the variables are I0, where co-integration will not apply. So let me cross it, because why to apply wrong results? Otherwise, all the commands are just like the Stata. Now we are moving to the equation. So GDP is our dependent variable, all other are independent variable, and we are going to apply PMG ARDL model test. And don't go for automatic selection, it will not run. So most of the cases, the software say no to run this. But here, surprisingly, we got the result. Okay, so this is the long run equation here, surprisingly significant. And the short run result are insignificant. The only difference we are having here, the software is taking 4 lags. So you can see that the software is taking lag 4. And if you want to see the selection, so this criteria graph is showing you that how to find out the optimum lag. So at lag 444, they find out the optimum model. In Stata, we are having some problem in taking the lag. So that's why if you want to take lag, EViews is better. So by 4 lag, we are getting the best result. And taking the 4 lag, the results are significant. So here, after considering the 4 lags of dependent and independent variable, we found that the long run is significant. And the co-integration, the error correction here is found to be insignificant. That is the problem. So the co-integrating equation coefficient is found to be insignificant. Okay. And these are all the short-run effects, and they are insignificant. So we have to change it. So let me take only 2 lags. So now we are having, but here this is the insignificant, and short run are significant now. And co-integration is also insignificant. So here, which lag we have to take? So there is no test which tell you that lag this is better, lag this is better. So you have to make permutation and combination as per my experience. So if I take lag 1, let me this is insignificant, significant. Dependent variable lag 1, independent variable lag 2. So let me check this. Okay. Or dependent variable, I can take up to lag 3, regressor up to lag 4. So you can take by this combination. So here I know that these are found to be significant, and this is also found to be significant. So this is a better result. So you know that how to play with the result basically. So long-term effect, by taking 2 lag in the dependent variable and 4 lag in independent variable, I can have this better result. Long-run effect are significant. It means gross capital formation, and FDI is having a significant effect on the GDP growth rate in long run. And if there is some error comes in the equilibrium, the correction rate is 84%, 0.84. Speed of adjustment, this is called speed of adjustment. And all the results are short run, and short run is saying that in short run, these variables are not having significant effect on GDP growth rate, but long run effect is significant. So this is sensible result. And if you want to see for individual countries, you can go for cross section short run coefficients. So you will get the short run effect for all the countries. So this result will tell you that some countries are highly sensitive. Like for example, in this case, you can see that all the short-term effect are significant. In some countries, it may not. Like you can see this country number 5, all short-term effect are significant. So GDP growth rate is highly affected by all the two variables. But in some countries, it may not be significant. But here I can, yeah, in this country number 12, you can see that the short-term effect is not significant. So by this result, you can report that which countries are highly sensitive and which countries are less sensitive. And you can also check the error correction is also different for all the countries. So in this way, the panel ARDL model is a complete package for writing the research paper. And if you have a good idea, so you can draw good results and convert it into a paper. So today, I think you have more clarity on the panel ARDL model, and you need to do some more research also if you want to go in detail. So from my side, that's it. Thank you very much. And if you have any query left, then we can discuss on that. So give me a minute.